All right, so this is exponential relationships. All right, so for DOK or DOK1, for the first bullet point, it says identify the y-intercept of this equation y equals 7 times 2 to the x. Okay, now we know that this is exponential because the exponent is x and it's small, so that's how you know that it's an exponential and it's to the first degree. All right, now when we're talking about the y-intercept or the base, we want to know where does it start on the y-axis, okay? Now we can see here that the equation is equal to y. So that lets us know that whatever equals on the right side, that equals some y value, okay? So that means that we want to know what is the y value when x is 0, because that is where it would intersect the y-axis, because that is where x is 0 and it's some type of y value. So you just plug in x for 0, and anything to the 0 power, no matter if it's 100, it's always equal to 1. So then this is equal to 7 times 1, y equals 7. So the y-intercept for this is 7. And the growth is going to be exponential growth. It's exponential growth because this is a whole number and it's positive. Okay. All right. Create an exponential equation with the decay 1/3 and a y-intercept of 2. So we have a decay of 1/3, and our y-intercept or base is equal to 2. Okay, so we have the y equals the amount times the rate times the time. Okay, so our base is going to be where we start. That's going to be initial amount. So A naught means initial amount. And that's what that 0 means. It's the beginning. Okay, so our initial amount is 2, and this is our rate. And it's a decay because it's a fraction. Okay, so then we're just going to plug it in the equation, and we're going to substitute this t for x because we want it to be in terms of x, because that is with the standard convention. So y equals 2 times 1/3 to the x power, and that's the equation for the excuse me, for the for the second bullet point. All right, create a table for the equation y equals 2/3 times 3 to the x power. All right, so we can take this equation, 2/3 times 3 to the x power. Okay, so I'm gonna do let's do 0, 1, 2, 3. And we're going to graph where x is the independent variable. Okay, so we're going to plug in x for the exponent. So we got 2/3 times 3 to the 0, 2/3 times 3 to the 1 power, three to the 1 power, 2/3 times 3 to the 2nd power, and then 2/3 times 3 to the 3 power. Okay, so like we said, anything to the 0 power is equal to 1. So then this is going to be 2/3, 3 to the 1 times 2/3, so that's 6/3, so that's 2. 3 to the 2nd power, that's 9. 9 times 2 is 18. 18 divided by 3 is 6. And then 3 to the 3 is 27 times 2. 27 times 2 is 54 divided by 3 is 18. So we can see as our x goes up, our y also goes up. So we know that's an exponential growth. So we have 2/3. 2/3 is 0.6. So we got 0.6, 2, 6, 18. And then it's so it's an exponential growth. Please leave any questions you have in the comment box. Okay. Now we're doing DOK2 for exponentials. All right. It says graph the. Oh, we just did that one. I'm sorry. Oh, no, we did. All right. So graph y equals 4, 2/3 to the x power. All right. So we're going to use this website called Desmo. And Desmo is just a graphing calculator, or it just graphs functions for you. All right, so just so you can see it, and you can do it the normal way or the longer way like we just did for the previous problem. We have y equals 4 times 2/3 to the x power. Okay, so we can see that this is a exponential decay because it's coming down, and that's because the rate is a fraction. Okay, compare and contrast the following graphs. Compare their growths and decay and y-intercepts. So that's for this problem here. All right, so this is the next bullet point for DOK2. Compare and contrast the growths and decay for y-intercepts. So all these are growths, okay? And the y-intercept is all one. They all share the same y-intercept. But they have different growths. Create an equation based on the table of values. So our table of values is x and y. So we got 1, 2, 3, 4. X is our independent variable, and y is our dependent variable. All right. So we're going to go back to our equation. Y equals the amount, or the or the amount times the rate times time, over how long it takes. All right. So we know that x is our independent variable. We know that y is our dependent variable. So the question is, what is our y-intercept? Where do we start? Okay. So remember, in order for us to start, x has to be equal to 0. Okay. So we know that x equals 0, y is going to be 0, because there's no x equals 0 here. Okay. So we can technically start off with y equals 4. So that can be our y-intercept. Actually, no, it's just there's no y-intercept. The y-intercept is 0. Okay, so it starts at 0, and then we want to look at the pattern and see, as the x is increasing, how is the y increasing? Is it linearly, exponentially, or quadratic? Obviously, it's exponential because it's exponential, but what is the exponential? So we have 4, and then if we do 4 squared, we get 16. Okay, and if we take out the square and replace it with 3, we'll get 64. And if we replace the 3 with a 4, quadruple 4, you get 256. So then the equation is going to be 4 to the x power. All right. We're doing DOK3. Which of the following models of exponential relationship justify your claim? A small bookstore with 100 books and sells about 1/4 of it remaining stock every year. Okay, so then the amount is 1,000. The rate is 1/4, and we're doing it with respect to time, which is going to be in years. So this is the exponential decay. All right, you are helping a soccer team tournament register participants. Each week, 6 teams sign up. So we have an initial amount of 0. So the rate is 6. Then each week, I'm sorry. So if we were to write out the table just so we can see it. Okay, so each week, 1, 2, 3, 4, 5, 6. And then each week, 6 teams sign up. So this is 6 plus 12 plus 18 plus 24, and then 30, and then 36. Okay, so we start off at 6, and then we keep going up. So this will actually be non-exponential. This will actually be linear. because you can see that